Hello everyone, welcome to the BYJU'S Exam Prep. I am Ajay Gupta and I welcome all of you in the class of 51 expected questions of electrical machine. So guys, as you all know that the GATE exam is in the offing. Only few days remain for the GATE exam and your preparation must be going into the full swing. So to boost up your preparation, the day before yesterday we started a series of 51 expected questions in the GATE exam. It is a wonderful concept and through this concept we are completely revising the electrical machine through the problems. Here we'll try to cover all the concept of electrical machine through these problems. So in these 2 days we have covered the transformer questions. We also cover the questions on the induction machine and we are trying to cover each and every concept of the transformer and the induction machine. So today we will discuss about some questions on the DC motor. So the modus operandi of the class is I will give you 3 to 4 minute time to solve this question. First you will try to solve this question by your own. After that I will discuss the detailed solution with all the concept related with that questions. Okay, so let's start. So sit with the pen, papers and the calculator. So first you should try to attempt all these questions by your own. This is about me. I am Ajay Gupta. I have more than 20 years experience in this field. I am the BTech from NIT Jaipur. I got the single digit rank both in EAC exam as well as in the GATE exam. I qualified EAC exam with both electrical as well as electronics branch, and I also selected in all the public sectors exams. I also work as a IRS officer in Indian Railway Power Grid Corporation, and I work in all the leading offline institute like Made Easy, Engineer Circle, IAS Academy, and before that I was working in an academy. So let's start with the first questions. Before starting, let me share some information to you. At 29 January at 8 p.m. the Rakesh Talreja sir will going to bring you a mega workshop for the GATE Aspirant 2023. Nothing is impossible. This session will be taken by the Rakesh sir and the Ankit sir on 29th January and the 30th January. Okay, so start guys with the first question. This is the first question from the DC generator. The question say a 20 kilowatt 440 volt short shunt DC generator has full load efficiency of 87%. If resistance of armature is 0.4 ohm and the resistance of interpole winding is 0.2 ohm, the series and shunt winding resistance are 0.25 and 240 ohm respectively. What is the combined bearing friction, windage and core loss of the machine? So this question is based on the electrical circuit of generator and power flow diagram of the generator. So I will give you 4 minute time to solve this question. Guys, I am giving you 4 minute time and your time starts now. This is a question from DC generator. You have to find out the mechanical losses. Friction plus windage losses is basically the mechanical losses and the core loss. The sum of core losses and the mechanical losses. First draw the circuit diagram of a short shunt DC generator and the power flow diagram, because this question is based on both concept, the circuit diagram of generator and the power flow diagram of the generator. Abhishek, I will provide the short notes of power system 2 within 2 days. So you can talk to Telegram group. I have given my Telegram ID, that is Ajay Gupta _JPR. This is a DC generator. 20 kilowatt would be the output power. Which option is correct? A, B, C or D? No option is matching. Try again. As per Anbu, B is the correct option. Still 1 minute 36 seconds left. Just draw the circuit diagram of a short shunt generator and the power flow diagram of the generator. You have to find out the sum of core losses and the mechanical losses. As per Ashok, D is the right option. Interpole winding is always connected in series of the armature circuit, so that the current in the interpole winding should be same as the current in the armature winding. As per Ayan Malik, now the B is the correct option. So Ayan Malik and Anbu, B is the correct option, and as per Ashok, the D is the correct option. Still you have left with 19 seconds. It is always better. Good evening, Subham. As per Srinivasan, B is the correct option. It is always better to read any questions 2 times. And underline the main highlight of the question. See, this is the 20 kilowatt. What is the 20 kilowatt? It is the input power or the output power? 20 kilowatt is always the output power. It is the output power at the time of rated condition. And at the rated condition means the full load condition. The full load efficiency of generator is given. It is the 87%. The resistance of armature winding, interpole winding and series and shunt winding is also given, and we have to find out the sum of core losses and the mechanical losses. So first let me draw the circuit of short shunt generator. In generator we give the mechanical power and it will give you the electrical output power. Short shunt is basically the cumulative generator. It has the series field winding as well as shunt field winding. This is the shunt field winding and this is the series field winding. This is the interpole winding. This is interpole winding, and interpole winding is connected with the armature circuit. So this is the armature resistance. This is my armature This is the armature resistance. The armature resistance and interpole winding is connected in the series. So whatever the connect is flowing in the armature, the same current should flow in the interpole winding. This is RSH, RSE. Now see, 20 kilowatt at 440 volt. What is the 440 watt? 440 volt will be the output power. The terminal voltage of generator is the 440 volt. So this is the 440 volt. At the rated condition, this is the rating of generator. That means at the full load condition, it would provide the 20 kilowatt power. So in the rated condition, it will provide the 20 kilowatt power. That means the 20,000 watt power. This is in the full load condition, and the full load efficiency is also given, that is the 87%. So full load efficiency is given, the output power we know, so we can also find out the input power. So input power at full load, sorry, it is not visible here, so I will write here, at full load efficiency is equivalent to output power divided by input power. Output power we know, it is the 20,000, and efficiency also you know, the full load efficiency is the 0.87. So the input power, input is the mechanical power, it is the 20,000 divided by 87%, that means 0.87. When we calculate, it would be 22988.5. So this is my input mechanical power at the time of full load condition. Is it clear? Now in the full load condition, if you know the voltage and you know the current, then you can easily find out the value of line current, how much line current it is providing. So the output current is at full load, it is 20,000 divided by 440. 20,000 is the power, voltage is 440. So from this equation we can find the line current, it is the 45.45 ampere. So this current is the 45.45 ampere, 45.45 ampere. If you know this current, then we can find out the voltage between these 2 points, voltage between A and B point, that is the voltage across the shunt field winding. So what will be the voltage across shunt field winding? It would be the 440 plus voltage drop across the series field winding. So voltage VAB, it is 440 volt 440 plus voltage drop across series field winding, and the voltage drop across series field winding is the current multiplied by series field winding resistance. The series field winding resistance is the 0.25. When we calculate, we will get 451.36. So voltage across shunt field winding is the 451.36. This is the voltage between these two terminals. Clear? So if you know the voltage across shunt field winding, you can easily find out the current that is flowing in the shunt field winding. It will be the voltage divided by the resistance of shunt field winding. So the current in the shunt field winding is VAB divided by the resistance of shunt field winding. It is 451.36. Shunt field winding resistance is 240. So divided by 240. So you will get the shunt field winding current is 1.88 ampere. So shunt field winding current is the 1.88 ampere. So this current is 1.88 ampere. Now what will be the armature current? It is a generator. So generator give the current and motor take the current. So IA, if you apply the Kirchhoff current law here, IA is equivalent to 45.44 plus 1.88. So armature current finally is the sum of line current plus shunt field winding current. 45.45 plus 1.88. Good evening, Diksha. It would come 47.33. Is it clear? This is my armature current. If you know the armature current, then you can easily find out the induced EMF in the armature. The induced EMF in the armature would be the voltage across VAB plus voltage drop across the interpole winding and the armature winding. So finally induced EMF in armature, it would be VAB, because VAB just we find out VAB plus voltage drop across armature winding and the interpole winding. So resistance of interpole winding plus armature winding. VAB was 451.36. Armature current 47.33, and the sum of these two resistance, armature current, armature winding and the interpole winding, is the 0.6. So when we calculate, we will get 479.75 volt. Is it clear? This is the value of EA. If you know the value of EA, then what is the electromagnetic power developed? Electromagnetic developed power. How to find out electromagnetic power? This is the EA multiplied by IA. If you multiply by EA with IA, you will get the electromagnetic developed power. So 479.75 and IA is 47.33. If we calculate, we will get 22706.96 watt. Is it clear? Okay, now come to the power flow diagram. You must know how the mechanical power is being converting into the electrical power. So in generator we give the mechanical power, and this mechanical power is converted into the electrical power. So this is my input power. We are giving input power to the shaft. So there will be some losses that will take place. These losses are no load core loss, mechanical loss plus stray losses, and here there is a electromagnetic power EAIA. After electromagnetic power, again you have a losses, that is the armature losses, copper loss in armature winding, and that is the copper loss in field winding. Field winding means the shunt winding as well as series winding. If you deduct all these losses, you will get this output power. This is my output power. So this is the power flow diagram of the DC motor, how the input mechanical power is being converting into the output electrical power. So we have to find out these losses, the no load core losses plus stray losses. Stray losses means in case of DC motor, if you increase the load, due to the armature reaction, the flux is changed. And if the flux is changed, that means the core loss is also changed. So this is my overall core losses at the time of load condition plus mechanical losses. So how to find out these losses? It is the difference of input power minus electromagnetic power. Input power minus electromagnetic power will be these losses. So core loss plus mechanical loss is the difference of input power minus electromagnetic power. Input power we calculated by using the formula of efficiency 22988.5, and electromagnetic power 22706.96. If you subtract 22706.96 from 22988.5, you will get 281.5 watt. ठीक है? Is it okay? So this questions, by using this question, just remember these power flow diagram, because power flow diagram is very important if you are going to find out the losses or if you are doing some questions on the efficiency of DC motor. And always remember that interpole winding and the compensating winding is always connected in series of the armature winding, so that whatever the current is flowing in the armature winding, the same amount of current should flow in interpole winding and the compensating winding. Because the main purpose of interpole winding and compensating winding is to nullify the effect of armature reaction, and the armature reaction occurs due to the armature current. Is it clear? Okay, so now move to the second questions. Second question is also from the generator. A 20 kilowatt DC generator deliver rated output at 1000 rpm at the terminal voltage of 500 volt. The armature resistance is given, which is 0.1 ohm, and the voltage drop per brush is 1 volt. The field resistance is 500 ohm. Calculate the speed at which machine will run as a motor. Earlier it was running as a generator. Now you would try to run it as a motor. Then what speed this machine will run when it were running as a motor? The motor taking the input of 20 kilowatt from 500 volt supply. So again I am giving you 4-minute time to solve this question, and your time start now. The machine earlier was running as a generator, and now you are going to run this machine as a motor. Use the formula of speed of the DC machine. Speed is directly proportional to the induced EMF and inversely proportional to the flux. So first, in case of generator, find out the induced EMF and the value of flux, and in case of motor, find out the value of induced EMF and the flux. Almost same type of question one times asked in the GATE exam. Ravi Ketan, don't discuss power system here. If you have any query, you can ask me in my WhatsApp. You can ask if you have any problem regarding the power system through my Telegram channel or through my WhatsApp number. It is very simple questions. Draw the diagram of DC generator and the DC motor. Find out the induced EMF. Note that the flux will remain same because the voltage is same. Speed is proportional to the induced EMF and inversely proportional to the flux. B976. As per the Diksha, B is the correct option. As per Ayan, B is the correct option. Okay, I will give my WhatsApp number to you. Neeraj, Ayan and Diksha, they have solved the question, and as per these guys the answer is B. Still you have 57 seconds left. Ashok is also getting the same answer. As per the Ram Balaji, the answer is B. So almost everyone is getting the same answer. You are left with the 10 seconds. And your time is going to end very soon. And your time is up. So many guys have solved this question. The answer was B. It was the 976 RPM. So let me do this question for you. In DC generator, we give the mechanical power and the output power is the electrical power. So I am drawing the circuit diagram of generator and motor. They are the shunt motor and shunt generator. Shunt field winding, armature winding, and this is armature. In DC generator is giving the 20 kilowatt power because it is delivering the rated output at the 1000 RPM, and 20 kilowatt is the rated output power. Suppose this is my generator and this is motor. It is giving 20 kilowatt output power at that time of full load condition, and it is rotating at the speed of 1000 RPM at the terminal voltage of 400 volt. The terminal voltage is the 400 volt. We have to find out the speed of machine when it is running as a motor. It take the input power of 20 kilowatt. When it is running as a motor, it also take the 20 kilowatt power at the same voltage 500 volt. So it is a 500 volt, not the 400 volt. It was the 500 volt. See, so First, I come to the generator. In case of generator, this line current will be 20,000 watt divided by 500. The line current 20,000 watt divided by 500. If you know the voltage and the power, you can easily find out the value of current. It comes 40 ampere. So this line current is the 40 ampere. Now the voltage across shunt field winding we know, and the shunt field winding resistance given, it is the 500 ohm. The resistance of shunt field winding is 500 ohm. And voltage across shunt field winding is also 500 ohm. So we can easily find out the value of, it is a generator. So generator, the current is coming out from the armature. So shunt field winding current would be 500 divided by 500. It is 1 ampere. So this is 1 ampere. If I apply the Kirchhoff current law here, I can get the value of IA. IA will be the 40 plus 1, yani 41. So IA will be the sum of line current and the shunt field winding current. It would be 40 plus 1, 41. क्या क्वेश्चन है, क्या कहना चाह रहा हूँ? Calculate the speed at which the machine will run as a motor, taking the input of 20 kilowatt from 500 volt supply. So you have to find out the speed of machine when it is running as a motor. ठीक है? Is it clear? चौधरी साहब हमारे नाराज हो गए. Okay, so we can easily find out the value of EA. जब भी कुछ सॉल्व करें ना, उस टाइम पे मत लिखा कीजिए, उसके बाद में लिखिए, अदरवाइज उस टाइम पे वो डिस्टर्बेंस होता है ना. So what is the value of induced EMF? It is the VT plus IARA. VT is the 500 volt plus IARA 41 into RA. RA is 0.1 plus overall brush voltage drop. So 1 volt is brush voltage drop is the 1 volt. So for the 2 volt brush, the voltage drop will be the 2 volt. If you calculate, you will get 506.1 volt. This is the value of EA. And this is the EAG, induced EMF in the generator. And the generator is rotating at the speed of 1000 RPM. It is given. We rotate the rotor of generator by using the prime mover. Now suppose if we start using this machine as a motor, then it will take the current from the supply and it will give you the mechanical output power. So again, the voltage across shunt field winding is the 500 volts. So you can easily find out the value of current. It will be 1 ampere. 500 divided by 500, 1 ampere. And now this line current is equivalent to 20,000 divided by 500. In case of motor, again the line current, the current which is drawing from the supply, it is 20,000 divided by 500. It is 40 ampere. Now if you apply the Kirchhoff current law here, the IA will be IL minus 1 ampere. Here the IA will be IL minus the current that is flowing in the shunt field winding. So it is the 40 minus 1. It is the 39. Yeah, this is brush voltage drop per brush. So for the 2 brush, you have to take the 2 volt. Because in a parallel path, we have 2 brushes. So always take the overall voltage drop of the brush. It is equivalent to the voltage drop per brush multiplied by 2, because in a parallel path we have 2 brushes. 39. Now if I find out EM is the induced EMF of the motor. So the induced EMF of the motor would be, now it will be the VT minus IARA minus brush voltage drop. VT is 500, IA is 39. What is the RA? RA is 0.9. Again, you have to take the voltage drop across the 2 brushes, because in a parallel path we always use the 2 brushes. When you calculate, you will get 491.1. Clear? Now what is the value of flux? See, the flux is depend upon the current that is flowing in the field winding. In case of generator, the current in the field winding was 1 ampere. In case of motor, the current in the field winding is also 1 ampere. So flux will remain same in both the cases, because the flux is created by the shunt field winding current. So flux will be same for motor and generator. So flux of motor and the flux of generator will always remain same. Now we know that the speed of a machine, it is EA divided by K phi. That means speed is directly proportional to induced EMF, inversely proportional to flux. So speed of generator divided by speed of motor. Induced EMF of generator, induced EMF of motor, flux of generator, flux of motor, because the flux is same, so it is equivalent to 1. Ng is given. When the motor was running as a generator, it was running at 1000 rpm speed. Now when this machine is working as a motor, what would be the speed? EAG was 506.1. and EM will be 491.1. From this formula, when you calculate the speed of motor, it would come 976.2 rpm. Is it clear? Yes, Mr. Rajyavardhan Chaudhary. चौधरी साहब, समझ में आया आपको? So always draw this circuit diagram. If you draw this circuit diagram, then you will easily escape the silly mistake. Okay, now we come to the question number 3. The armature winding of a 200 volt 4-pole series motor is lap wounded. There are 2 80 slots. Each slot has 4 conductors. The current is 45 ampere and the flux per pole is 18 milliweber. The field and armature winding resistance is given. The iron plus friction losses, the iron losses plus friction losses, that means the mechanical losses, is equivalent to the 800 watt. The pulley diameter is 0.406. Find the pull in Newton at the rim of pulley. By using the motor, we are running a pulley and you have to find out the pull in Newton. Newton means the force on the pulley. मोटर को हम लोग यूज कर रहे हैं पुली को रन करने के लिए, उस पुली के ऊपर कितना फोर्स लग रहा है वो आपको यहां पर फाइंड आउट करना है. ओके, ट्राई टू कंप्लीट दिस क्वेश्चन विद इन 4 minutes and your time start now. Always remember the torque is force multiplied by a radius. So first find out the value of torque and divide it by radius. So you can find the value of force. Total number of slot is given. Total number of conductor in per slot is given. It is a series motor. That means the field winding is connected in series of armature winding. Use power flow diagram as I used earlier. This is given. Sum of the mechanical losses plus iron losses, core loss is given 632. Lakshman Meena ji 672. First think, what would be the output torque, whether it would be the developed torque or it would be the shaft torque. Hi Lakshman, how are you? What would be the torque that you are getting at the pulley, whether it would be the developed electromagnetic torque or it would be the shaft torque. Yes, tell me what it should be, whether it should be the shaft torque or the developed electromagnetic torque. Yes, Ayan is right. It should be the shaft torque. So to find out the shaft torque, first find out the shaft power. That is the net power which is available at the shaft. As per Ayan, C is the right option, 672. Ayan, please check again. Srinivasan, what is your answer? And Ashoka the Great. Oh, only 3 seconds remain. And your time is up. Yes, Lakshman, you are also right. It is the shaft power. So we have to find out the force that exists at the rim of pulley, and since we know the force is nothing but the force, torque is nothing but the force multiplied by radius. So if you know the shaft torque, it is the force multiplied by a radius of pulley. To find out the value of force, just find out the shaft torque, because the force will nothing but the shaft torque divided by radius, and radius is given. So just need to find out the value of shaft torque. Okay, now how you can find out the shaft torque? Shaft torque is nothing but the shaft power divided by omega. That means the speed in radian per second. If you divide power with the speed radian per second, you will get the shaft torque. So what is the shaft torque? Shaft torque is exactly torque that is available at the output. So now see this power flow diagram. This is my shaft power. This is the shaft power. So what will be the shaft power? If I know this power EIA, and this is the this is the for motor, that was for generator. So I am drawing for motor the same power flow diagram. In case of motor, we give the electrical power. This is my electrical power, input power. This is EAIA, electromagnetic power. There would be armature copper loss or field winding copper loss. Now here we have iron losses plus mechanical losses. It is opposite to the diagram that we have drawn earlier for the generator. And this is my output power. Output power is the shaft power. So shaft power is nothing but the developed power minus iron losses plus mechanical losses. Clear? So if I find out the value of EAIA and I deduct iron losses and mechanical losses plus electromechanical power, I would definitely get the shaft power. The iron losses plus mechanical losses is already given. It is equivalent to the 800 watts. So just we need to find out the value of EAIA. So how to find out EAIA? Let me draw the diagram of series motor. In series motor, the field winding is connected in series of armature. This is series field winding. It is connected in series of armature winding. (200 volt) 4-pole series motor. That means the voltage that we are applying at that terminal is 200 volt. And resistance of field winding is 0.3 and resistance of armature winding it is 0.3 and resistance of armature winding is 0.5. Current flowing is the 45 ampere. Current is flowing, it is the 45 ampere. So what will be the value of EA? So you can easily find out the value of EA. EA will be VT minus IA RAC plus RA. VT is the 200 volt, IA is 45 ampere, RA plus RAC 0.5 plus 0.3. What it would be? If you calculate this, you will get the value of 164. So you find out the value of EA. Okay. So you know the EA and you also know the IA. So you can easily find out the PSH. Now the PSH is EA into IA, 164, IA is 45 ampere, minus iron losses and mechanical losses. Iron losses, mechanical is the 800 watt. Clear? So it would come 6580. Thank you, M. Kumar. It is a 6580 watt. So we find out the value of PSH, but now we have to find out the value of TSH. To find out the value of TSH, we require the value of omega. Omega means the speed in radian per second. So first we have to find out the value of speed. So how to find out the speed here? By using these data. We know the total number of conductor, we know the flux per pole. So and we already calculate the induced EMF. So use the equation of induced EMF. How to find out the speed? If I use the formula to find out the induced EMF, it is the P phi Zn divided by 60A. You know this formula? Here N is the speed rotation per minute. So we know EA, we know P, we know phi, Z and A. So you can easily find out the value of N. EA just find out 164. Total number of pole, it is given. It is a 4-pole machine. Flux per pole. Flux per pole is 18 milliweber. Total number of conductor. See, in total machine, there are total 280 slot and each slot has the 4 conductors. So total conductor in the machine would become 280 multiplied by 4. So it is the 280 multiplied by 4. Speed we have to find out. Divide by 60A. A is the parallel path. To find out the parallel path, you have to see whether it is a lap winding or the wave winding. It is a lap winding. In the lap winding, A is equivalent to P. A की वैल्यू पैल पोल के इक्वलेंट होती है, यानी इट इज ए 4. So for lap winding, number of parallel path is equivalent to the number of pole. So from these data you can find out the value of speed. It would come 484 rpm. Is it clear? This is in the rpm. So now what is the shaft torque? It is the shaft power divided by speed in radian per second, and speed in radian per second is become 2 pi n into 60, 2 pi n by 60. PSH is 6580. 60 divided by 2 pi n. N is the 484. If you calculate, you will get 128.8 Newton meter. So this is my shaft torque, the torque that is available at the shaft of machine. So if you know the shaft torque, you can find out the force. Force is torque divided by radius of pulley. 128.4, and the radius of pulley is given. The diameter is given 0.406. So radius will be the half of this. It will be 203. 0.203. It will come 634. Clear? तो आपको देखिए कैसे देखना है, आपको ऐसा पूरा देखना है कि आपको जैसे फोर्स की वैल्यू फाइंड आउट करनी है. हाउ टू फाइंड आउट द वैल्यू ऑफ फोर्स. फोर्स आपका निकलता है टॉर्क के ऊपर. फर्स्ट मिस्टेक यू कैन कमिट हेयर, इंस्टेड ऑफ यूजिंग शाफ्ट टॉर्क यू कैन यूज द इलेक्ट्रोमैग्नेटिक टॉर्क. अगर आपने इलेक्ट्रोमैग्नेटिक टॉर्क यूज किया तो आपका गलत हो जाएगा यहाँ पर. ठीक है, पहला मिस्टेक आप यहाँ पर कर सकते हो. एंड यू मस्ट नो अबाउट द पावर फ्लो डायग्राम. सो बाय यूजिंग दिस पावर फ्लो डायग्राम you can easily find out the value of shaft power. And how to find out the speed? To find out the value of speed, you have to use this formula. So ultimately B is the correct option. 634 is the correct options. Clear hai? Should I move to the next question now? Okay, now we come to the question number 4. Two shunt generator. It may be tough question for you. And battery are working in parallel. There is 3 power source. 2 is a shunt generator and 1 is a battery. Everybody is a power source. The open circuit voltage, armature resistance and the field winding resistance of generator are. This is the generator for generator number 1 and these are for generator number 2. If generator supply the same current, both generator is supplying the same value of current and the load on the bus bar is 40 ampere. This means the total current that is provided by these two shunt generator plus battery is equivalent to 40 ampere because all 3 power source is providing power to the bus bars. This is complete current. So what is the EMF of battery when the internal impedance of battery is 0.172? Okay, I am giving 4-minute time and your time is start. Sorry, your time is start now. There are 3 power source, 2 is shunt generator and 1 is battery. All 3 supplying power to a bus bar. The total current on the bus bar is 40 ampere. That means the sum of all current. The sum of current by generator all two generator, and the battery is equivalent to 40. The open circuit voltage, armature resistance and field winding resistance is given. The generator is supplying the same amount of current. What is the internal impedance of battery? You have 2 minutes 30 seconds. Open circuit voltage means the induced EMF. When the no current is flowing, that means the terminal voltage is equivalent to the induced EMF. So it is the 250 and the 240. You still have 1 minute 15 seconds. Espresso C is the right option. No. Only 50 seconds left. Three sources there, two are the sun generator and one is battery, and they all three are providing power to a bus bar. The total current is equivalent to the 40 ampere. As per Ayan, 251D is the correct option. प्रभाकर चौधरी जी के अकॉर्डिंग भी D ही करेक्ट आंसर है. So there are so many Chaudhary today. नीरज के अकॉर्डिंग डी, वैभव के अकॉर्डिंग डी. यस लक्ष्मण, व्हाट इज योर आंसर? वैभव इज डी. नो. See, two sun generator and the battery, they combinedly providing power to a bus bar. So if I draw sun generator, this is my one sun generator. Armature resistance, shunt field winding resistance. Armature resistance is 0.24 and shunt winding resistance is 100 ohm. It is 100 ohm and this is 0.24. This is my generator number 1. Now come to the generator number 2. Suppose I draw it with red marker. This is again a shunt generator. In this shunt generator, the field winding resistance is 248 and the armature resistance is 0.12. It is 100 ohm, but this is 0.12. Clear? And again there is a battery. One battery is also there. In battery has some internal resistance and some constant voltage source. This is the battery. All three providing power to a bus bar. All three is providing power. Sorry. It is giving power. It is also giving power. It is also giving power. This is a DC bus bar. DC bus bar would be one bus would be positive terminal and bus would be a negative terminal. So it is given the current given by both generator are same. So it is same I and I. No doubt all three are connected in parallel, so the voltage would be same. Suppose they all are providing, this is my bus bar voltage V. So this is the V. So what is the voltage across this shunt winding? It is also V. So the current that is flowing here, it would be V upon 100, because the voltage across shunt field winding is the V. Similarly, voltage across this shunt field winding is also V. So voltage current that is flowing in this shunt field winding is again V upon 100. So suppose this is the armature current of second generator and this is armature current of first generator, IA1. So what will be the IA1? It is equivalent to I plus V upon 100. I is the current given by the shunt generator and both generator give the same amount of current. It is given. Generator supply the same current, that is I took I and I for both. Similarly for IA2, it is again I upon V upon 100. Is it clear? Suppose the induced EMF here is EA1 and the induced EMF here is EA2. So how to find out the induced EMF? EA1, it is the V, terminal voltage is the V plus IaRa. IA is this, IA is I plus V upon 100 into RA. RA is 0.24. Is it clear? And what is this EA1? EA1 is the no load induced EMF. It is given, it is 250. The open circuit voltage is the 250. So it is the 250. So 250 V plus I plus V upon 100 divide by multiply by 0.24. This is equation number 1 for generator 1. Now come to the generator 2. In generator 2 also you can use this equation. EA2 will be terminal voltage plus IaRa, and generator 2 current is the same I plus V upon 100. But armature resistance is here 0.12 and this E2 is given. The no load voltage of second generator is 248. So it is 248. Equal to V plus I plus V upon 100 into 0.12. This is my equation number 2. Clear? So from these two equations, we have a two variable V and I and we have a two equation. So जितने equations चाहिए होते उतने variable होते हैं. You can solve these equation to find out the value of V and I. If you solve these equation, you can get the value of V and I. So from equation number 1 and equation number 2, we can find out the value of voltage and current. The V would come 246 and I is coming 14.2 ampere. Clear? Now see, it is given the load on the bus bar is 40 ampere. That means the total current on the bus bar is 40 ampere. So suppose if current through the battery is IB, so if I use the Kirchhoff current law here, IB plus I is equivalent to 40 ampere. So what is the 40 ampere? Current through the two shunt generators is 2I, current through the battery is IB, it is equivalent to 40 ampere. So we can find out the value of IB. It is the 40 minus 2 into I we just find out, it is the 14.2. So from this we just calculate the value of IB. It is the 11.6 ampere. If you know this 11 upon 6 ampere, then what is the value of EB? EB is nothing but the V plus voltage drop across internal resistance. So finally we have to find out EB. It is nothing but the voltage plus voltage drop across the internal resistance. V is 246, I is 11.6 and RB is given. Internal impedance is 0.172. If you calculate this, you will get 248 volt. Clear? Again I am telling, do not feel demotivated if you fail to do this problem. Just try to understand the new concept so that whenever you appear in the GATE exam, you should be confident enough that you have an edge over the other student. You know something extra as compared to other student. Clear? So 248 was the right options. Okay, thank you Rajesh. Now I come to the question number 5. A 4-pole DC shunt generator with a shunt field resistance of 100 ohm and armature resistance of 1 ohm. It has 378 wave connected conductor in its armature. The flux per pole is 0.02 Weber. If load resistance of 10 ohm is connected across the armature terminal and generator is driven at 1000 rpm, calculate the power absorbed by the load. Again I am giving you the 4-minute time and your time start now. This 378 is the total number of wave connected generator. It is a DC shunt generator. Shunt field winding resistance is given. Armature resistance is given. Total conductor is 378. Flux per pole is given. The load resistance, it is also given. The load that is connected at the terminal of generator is the 10 ohm. And generator is driven with 1000 rpm speed. How much the power is being absorbed by the load? 1 minute 58 seconds remain. B 4219. No. The resistance of load is also given. It is the 10 ohm. And you have to find out how much the power is absorbed by the 10 ohm resistance. As per Prabhakar Chaudhary, A is the correct option. चौधरी साहब के अकॉर्डिंग ए करेक्ट आंसर है. अशोका द ग्रेट के अकॉर्डिंग भी ए इज द करेक्ट ऑप्शन. Just always draw the circuit diagram of generator and motor. You can always reduce the silly mistake when you are attempting the question while drawing the circuit diagram. As Prayan Malik, A is the right option. So finally, 3 students mark the correct answer, and no doubt A is the correct options. See, first I will draw the circuit diagram of shunt generator. In shunt generator, we have a shunt field winding. We have armature and load is also connected. The load value is the 10 ohm resistance. This is shunt winding resistance, armature resistance, RSH, RA, this is load resistance, RL, armature. Shunt winding resistance is the 100 ohm, RSH is given, and series winding resistance is also given, not given, sorry, armature resistance is given, it is 1 ohm, and load resistance is 10 ohm, flux is given. Suppose if the terminal voltage across the load, if you know the terminal voltage across the load V, or if you know the current that is flowing through the load, then you can easily find out the power absorbed by the load resistance V multiplied by L. So if we assume the voltage across load is V, then the voltage across shunt field winding is also the V. So the current that will flow in the shunt winding is become V upon 100. V divided by the resistance of shunt field winding. Suppose this is the value of armature current. We can find out the value of EA by using the formula of EA, because we know the total number of conductor, we know the flux per pole. So the induced EMF EA we can directly find out by using P phi Zn divided by 60 into A by using this formula. Total number of pole is the 4. Flux per pole is given 0.02 Weber. Total number of conductor is given 378. The speed at which generator is rotating is the 1000 RPM. Divide by 60A. Now what is the A? A is the total number of parallel path, and this is a wave winding. In case of wave winding, A is always equivalent to 2. So by using this formula, first we can find out the value of EA. If you find out the value of EA, you will get 252 volt. This is the 252 volt. Clear? See, this was my V upon 100. If the voltage across load resistance is V and load resistance value is 10, so this IL is become V upon 10, because the voltage is given and resistance is given, not 100, V upon 10, sorry. So now my total current IA, if I apply the Kirchhoff current law here, it will be the V upon 100 plus V upon 10. Clear? This current is equivalent to V upon 100 plus V upon 10. V upon 100 plus V upon 10. If you take 100 as a LCM, you will get 11 V upon 100. This is my armature value of current. Now we know the V is nothing but induced EMF minus IA into RA. V is the V. EA we just find out, it is 252. IA is in term of voltage, we know it is the 11 V upon 100. This is my IA. And resistance is 1 ohm. Armature resistance is 1 ohm. So from this formula we can easily find out the value of V. It will be 227. So this is my terminal voltage. If you know V, you can find out the value of I. We don't need IA, we need IL only. So IL is V upon 10. 227 divided by 10. It is the 22.7. If you know the voltage across the load resistance and the current that is flowing through the load resistance, you can find out how much power the load is taking. It is the voltage across load, the current through the load. 227 multiplied by 22 by 7. It would be 5153 watt. So this is the power taken by the load. Clear? Yes, Srivastav ji, you are right. A is the right option. So many students is able to do this question. Okay, so should we move next question? So I am moving towards the question number 6. A 4-pole, again wave wound DC armature has a bore diameter. Bore means the diameter of a pole. Bore diameter is 71.12 centimeter. It has 520 conductor and the ratio of pole arc to pole pitch is 0.63. If armature is running at 720 rpm and the flux density in air gap is 1.6 Weber per meter square, it is not dash, it is the 1.6 Weber per meter square. Calculate the EMF in the armature. Effective length of armature conductor is given. Effective length means, suppose this is my armature. This is a conductor. So this is the effective length of conductor because the EMF is induced only in the case of conductor. A single turn has the 2 conductor. This is the effective number of 2 conductor. My telegram link is Ajay Gupta _JPR. I share all the PDF of these classes on my telegram ID. Clear? So how much time you require to solve this question? 4 minutes would be sufficient. Okay, so time start now. Just you have to use the formula of induced EMF. But here everything is given. The pole arc and pole pitch is also given. P5Zn divided by 60A. You have to use that formula. Just find out the value of flux. For that, the flux density is given. Flux density multiply by area. Don't use approximate formula because here you can find out the value of flux per pole exactly. B1429. As per Ayan, B is the right option. Let the other students should also answer the question. As per Neeraj Kumar Maurya, B is the right option. Still you have 1 minute 27 seconds to solve this question. Bevav B, Diksha B. Just find out the exact value of flux per pole. Don't go with the approximate formula of flux per pole. Pole pitch is basically the peripheral distance between the two adjacent poles is called the pole pitch, and pole pitch is always measured in terms of electrical degree. And in terms of electrical degree, the pole pitch is always 180 degree electrical. So as per Ajay, B is the right option. Prabhakar Chaudhary, B is right option. Okay, so your time ends now here. See, suppose, let me use suppose this is the armature. Armature means it is a part of rotor, and the stator has the pole. Suppose I am drawing the one pole of the stator. Is it clear? it is the pole, field winding pole. It is like this. Generally we draw it in a 2-dimension case. It is this one. So I've drawn it in the 3-dimension. So see, the bore diameter is given. Bore diameter is given. It is 71.72. So what is the peripheral surface area? Surface area is 2 pi RL or pi d. Surface area of a cylinder, it is a 2 pi RL. See, even this is complete. Forget about the surface area of a cylinder. Just use the area of a circle. The circle that would be made by the stator. Surface area will be 2 pi r or pi multiplied by d. It has the 4 pole. So pole pitch is always in term of angle. It is the pi d. Here it is not in term, यहाँ पर जो मैं निकाला it is not in term of angle. Here it is in term of meter. So pi d divided by the total number of pole. It is the total number of pole pitch. Here I am not taking pole pitch in term of angle. I am taking it in term of meter or centimeter. So we know the value of pi. D is given. D is 71.12 centimeter. And the total number of pole is the 4 pole. It is in term of centimeter. This is my pole pitch. Now the pole pitch to pole arc or pole arc to pole pitch. It is 0.63. So from this we can find out the value of pole arc. It is 0.63 multiplied by pole pitch, pi into 71.12 divided by 4. Is it clear? See, overall this length is pi multiplied by d or the 2 pi r. So if I find out the length between the pole, it is the pole pitch. I divide it because it has the two. This is I have drawn only one pole. In this machine we have a 4 pole of this type. So the length of one pole, it is the 0.63. But this is my pole pitch. See, it is called the pole pitch. This is the pole pitch. Pole pitch to pole arc, sorry, this is pole arc. Pole arc. Pole pitch is the distance between the two adjacent pole. So from this we just find out the distance between this distance. This is my pole arc. If I multiply this distance by length, I can get the area of a single pole. So area of a pole is like the area of a rectangle. Assume it is almost a rectangle. This is the length multiplied by width. So it is the 0.63 multiplied by pi into 71.12 multiplied by 4, and the length is given. Length of a effective length is the 20.32 centimeter. So if you calculate, you will get 715.3. It is in term of centimeter square, so it would be 715.3 into 10 raised to the power minus 4 meter square. Clear? This is the area of a pole. So now what is the flux? Area of a pole, flux density multiplied by area of a pole. So this is the flux per pole. This is my flux per pole. Phi is always flux per pole. Flux density multiplied by area of a pole. Flux density we know it is 1.6 Weber meter square, and area of a single pole is into 10 raised to the power minus 4. So from this, if we calculate, it would come 1175 Weber. Now you use this flux in this formula, P phi Zn divide by 60A. P, number of pole is 4. Phi is 0.1145. Total number of conductor is 520. Speed (720 RPM). 60 into A. For the lap wound, A is equivalent to 2. So from this equation you can find out the value of E. Is it clear? See, here we are using the exact equation. Otherwise, how we calculate? Generally we find out flux in this way. Flux density, normally we use this formula. Flux density, flux is the flux per pole, multiply by area of a pole. So generally we find out the area. The overall area is the 2 pi r into L. This is my surface area, and we divide it by number of pole. So this is basically the approximate formula to find out the flux per pole, because the flux is only existing between the pole arc. Suppose if I draw the 4-pole machine, let me tell you in detail. Suppose we have a 4-pole here. This is pole number 1. This is pole number 2. Pole number 3. Pole number 4. So when we are using this approximate equation, 2 pi RL divided by pi, this is my 2 pi R, L is length, divided by pi, we get this much of length. This is my pole pitch 2 pi L. अगर मैं इसको 4 पार्ट में इक्वली डिवाइड करूँ तो ऐसा आएगा ना ये, बट एग्जैक्टली it is like this. This is my pole arc. So this is the pole arc, and green one is the pole pitch. Now it is clear. Since the pole arc oblique pole pitch is given, so we can exactly find out the value of area of a pole. So this green one is the pole arc, sorry, red one is the pole arc, and the green one is the pole pitch. Clear? Okay. So now we move to the next question. The hysteresis losses and the eddy current losses of a DC machine running at 1000 RPM is the 250 watt and 1000 watt respectively. If flux remain constant, then at what speed the total iron loss is halved? Again I am giving 4-minute time to solve this question. and your time start now. At the speed of 1000 rpm, the hysteresis losses is the 250 watt and the eddy current losses is the 100 watt. If the flux is remain constant, then at what speed the total iron loss would be halved. यानी किस स्पीड के ऊपर टोटल आयरन लॉसेस की वैल्यू हाफ हो जाएगी. (800 rpm, 756 rpm, 570 rpm और 450 rpm. Remember, the hysteresis losses and the eddy current losses depend upon the value of frequency, and the frequency of induced EMF is depend upon the speed. It depend upon the relative velocity between the conductor and the magnetic field. As per Prabhakar Chaudhary ji, B is the right option. As per Ashok, it is also B. The total iron loss we halved. Total iron loss is the 350 watt. So at which speed the total iron loss will be the 350 divided by 2. That is 175 watt. Can you tell me in which part the iron losses occur in case of DC machine? The iron losses occur in field core or iron core or at both the core, because the field winding also has the core and the armature winding is also has the core. So where the iron losses occurs? At both the core or at only one core? At per the Neeraj Kumar Maurya, C is the correct answer. Srivastav जी के अकॉर्डिंग भी C आंसर है. As per Srivastav, the iron losses occur only at armature. See, in the DC machine, the DC current flowing in the field winding. So flux in the field winding, the flux created by the field winding is the DC in nature. And if the flux is constant in magnitude, that means the no EMF is induced in the DC core. If no EMF is inducing in the DC core, that means the no eddy current is flowing in the field core. But even if it is a DC machine, the induced EMF in the armature is always in alternating in nature. Only it is because of the commutator and the brushes we are getting DC in the outer circuit. Otherwise the induced EMF is AC in nature. So in the armature winding, the induced EMF is AC in nature, and due to this alternating nature of induced EMF, the eddy current also flow in the armature core. So the core loss occur only in case of armature winding. Is it clear? So how this loss is related with the speed? See, we know hysteresis losses depend upon hysteresis losses is proportional to flux frequency and the eddy current losses is proportional to the frequency square, we know. ठीक है. Frequency I just Srivastav just told me that the core losses is taking place only in case of armature due to the alternating nature of induced EMF in the armature. So frequency of induced EMF. What is the frequency of induced EMF in armature? EMF is being induced as per the Faraday law and it depends upon the total number of pole speed divided by 120. This formula is applicable for everywhere, for the DC machine as well as for the induction machine. It is a normal formula. Due to the relative velocity between the coil and magnetic field, the EMF is induced and the frequency of induced EMF is depend upon the pole and the speed. So frequency is, if pole is constant, we are not changing the pole. So frequency is depend upon the speed. So hysteresis losses is directly proportional to speed and eddy current losses is directly proportional to speed square. Almost same type of question come into the gate exam. It is, suppose if I use a two constant, it is become A multiplied by N and P is become B multiplied by N square. So at the speed of 1000 RPM, at N equivalent to 1000 RPM, the hysteresis losses is given, it is the 250 watt. It is the 250 watt. A into 1000. So from this formula we can find out the value of A. It is become 250 upon 1000 means 1 upon 4. Clear? And eddy current losses is 100 watt only. 100 watt B into N square. N is the 1000 RPM. So from this you can find out the value of B. It is 100 upon 10 raised to the power 6. So it is 1 upon 10 raised to the power 4. Because the hysteresis losses and eddy current losses at a particular speed is given. So from this you can find out the value of A and B. Now we have to find out the speed at which this core loss is halved. So total core loss is initially the total core loss. It is the sum of hysteresis losses and the eddy current losses. 250 plus 100. So total core loss was 350 watt. At what speed? Suppose at speed of N, just imagine that at speed of N, this core loss will become half of the 350. It is 175. So see, total core loss is the sum of hysteresis losses and the eddy current losses. It is A multiplied by N and it is a B into N square. So at the speed of N, this core loss would become 175. Now we have to find out the value of N only. A and B की value में पता है A is 1 upon 4 into N. B is 1 upon 10 raised to the power 4 into N square. 175. Now by using this formula, this would be a quadratic equation. By using this equation you can find out the value of N. क्या आ जाएगा ये? It would be 4N square plus 10 raised to the power 4N 175 into 4 into 10 raised to the power 4. Now you have to solve this quadratic equation to find out the value of N. If you solve this quadratic equation, you will get the value of 570 RPM. भास्कर पटेल, ऑनलाइन लाइव क्लास के बारे में बताओ. ऑनलाइन क्लास ऑनलाइन होती है यानी यूट्यूब के ऊपर होती है. टाइम मतलब जो भी क्लास होता है सबका अपना अलग अलग होता है. जैसे अभी जो क्लास चल रही है दैट इज द गेट स्पेसिफिक. द स्टूडेंट हु इज appearing in the gate 2022 और who are planning to appear in the gate 2023, उसके लिए 51 एक्सपेक्टेड क्वेश्चंस की क्लासेस है जो एग्जाम्स के अंदर आ सकते हैं. इट विल बूस्ट योर नॉलेज इन द इलेक्ट्रिकल मशीन. बाकी पूरे दिन भर क्लास चलती रहती है. जब भी आपकी इच्छा हो आप देख लीजिए. अलग अलग फैकल्टी की अलग अलग क्लास होती है. बाईजू में नहीं है, सब्जेक्ट वाइज सब्सक्रिप्शन नहीं होता है. क्लियर है? जस्ट रिमेंबर दिस थिंग. The frequency is proportional to the relative velocity. So the hysteresis losses and eddy current losses will depend upon the speed and speed square. Clear? Okay, so I'm moving to the next question. Two series motor run at the speed of 500 rpm and 550 rpm respectively when taking 50 ampere current at 500 volt. The terminal resistance means the combined resistance of armature winding and the series field winding of each motor is 0.5. Calculate the speed of combination when they are connected in series. Electrically they are connected in series and mechanically they are coupled on the same shaft. Now this combination is taking 50 ampere current from the 500 volt supply. It's a very interesting question. Try to solve this question within 4 minutes. The question from the speed control of DC machine. It is a part of armature voltage control method. Both series motor is running at the speed of 500 rpm and 550 rpm. When we connect these series motor electrically in series and mechanically coupled, then what is the speed of the combination if it is taking 50 ampere from the 500 volt supply? Armature, it is a part of armature voltage control method. If you connect series motor in series, then the voltage across armature is become half. So the speed will be changed. Individually speed has been given. Now we are connecting these series motor electrically in series and mechanically in a same shaft. DC machine considered as a most easy topic of electrical machine. Always draw the circuit diagram first to reduce the silly mistake. Terminal resistance means the combined resistance of armature winding and the series field winding. As per Ashoka the Great, it is C 345. .500 volt is the terminal voltage. As per Patel, B is the right option. Still you have 16 seconds. Shakti Kapoor, AU के according correct answer is B. Okay, your time is up. Now let me solve this question for you. First I will draw the series motor. Series motor has the series field winding. This is armature resistance. Series field winding RAC. Both motor run at the speed of 500 rpm. Different speed they are running, but they are connected with the same 500 volt supply terminal. So they are connected with the 500 volt supply terminal. Since it is a motor, so it will be draw current from the supply. It is taking 50 ampere current. Both motors taking 50 ampere current from the supply. RA plus RAC is given. Terminal resistance means the combination of both resistance is the 0.5. So what is the induced EMF? If we know the terminal voltage, current and this resistance, then we can easily find out the value of induced EMF. In both machine, the induced EMF will be same. So induced EMF in both machine. It will be terminal voltage minus IA, RA plus RAC. Terminal voltage is the 500, IA 50 ampere into 0.5. It would come 475 volt. So induced EMF in both the motor is the 475. Okay, but they are running at the different speed. So we know induced EMF is nothing but the K phi into omega. It depends upon the value of flux and the speed. It is the speed in radian per second. You can also write it in this way. It is 2 pi n upon 60 because speed is given in the rotation per minute here. So it depends upon EA is basically proportional to the flux and value of speed. Suppose if I use a constant K here, K phi into n. The flux here is the phi 1. Suppose here flux is the phi 1. EA we just find out 475. It is rotating at the speed of 500 rpm. EA is 475. K phi 1 into 500 rpm. So from this we can find out the value of K phi 1. This is for the motor number 1. Now find out same thing for motor number 2. In motor number 2 also the EA is proportional to flux and speed. Suppose here flux is the phi 2, here flux was phi 1. So EA will be K multiplied by phi 2 into n. EA is same 475, but the second motor is running at the speed of 550 rpm. So from this we can find out the value of K phi 2. It is become 475 divided by 550. This is my equation number 1 and equation number 2. Is it clear up to this time point? So दोनों मोटर के लिए मैंने K phi 1 और K phi 2 इसकी वैल्यू मैंने फाइंड आउट कर ली है. Now these two motors is connected electrically in series and they are mechanically on the same shaft. So I am connecting these two motors electrically in series. See, this is my first motor. And I am drawing the second motor. With the different color. This is series field winding, armature resistance. Suppose I am using volt 2 here. And this is the induced EMF of second motor. This is series field winding of first motor, armature resistance of first motor, and armature induced EMF is, suppose it is EA1. So both motor is connected electrically in series. Series में connect कर दीजिए. With the same supply of 400 volt. The terminal voltage of this combination of motor is the 400 volt. Since both motor are on the same shaft, so both motor will run 500 volt, sorry, at the same speed. Clear? Both motor is mechanically coupled. At same speed. ठीक है. Suppose again it is taking 50 ampere current. The combination is also taking 50 ampere current. So if you apply the KVL here, 500 minus this much, you can find out the sum of EA1 plus EA2. If I apply the KVL here, so the 500 will be equivalent to EA1 plus EA2 plus voltage drop across RA1 plus RAC1. Current is the 50 ampere. And voltage drop across RA2 and RAC2. Clear? RAC1 and RAC2. So this is 500. Sum of induced EMF EA1 and EA2 when these two motor is running at the speed of n. मैंने यहाँ पर n मान लिया. So 50. Terminal resistance was 0.5 for both the motor. 25 50 हो जाएगा. So it is become EA1 plus EA2 is become 500 minus 50, that is the 450 volt. So sum of the induced EMF, suppose when the motor is running at the speed of n, we are assuming that it is running at the speed of n. Now we know EA is proportional to K phi into n. So EA1 is equivalent to K into phi 1 into n, and EA2 it is to K into phi 2 into n. Both motor is now run at the same speed n is equivalent to 450, but we know the value of K phi 1 and K phi 2. K phi 1 was 475 upon 500. And K phi 2 is 475 by 550. If you solve this equation, you will get the value of n equivalent to 248 RPM. This is a very unique question. You hardly do this type of question in case of speed control of DC motor. And it's a very interesting question. So when these motors are mechanically coupled, they would run at the same speed n. Clear? Okay, so I'm moving towards next question, the question number 9. It is also from the speed control because the maximum number of questions in DC motor come from the topic of speed control. A 4-pole 340 volt series motor run at 1000 rpm when the load current is 12 ampere, which is the load current, and the series field winding resistance is 0.8. Armature resistance is 1 ohm. The series field coil are now regrouped to form all in series to 2 in series because we have a 4-pole machine. So every pole has the field winding, Suppose this is my pole. So every pole has a field winding. So basically you have 4 field winding. So earlier all 4 field winding is connected in series. But now they are regrouped to form all series to 2 in series. Now there are 2 field winding is connected in the series and these 2 are connected in parallel. Clear? The line current is now again 20 ampere. If the corresponding weakening of field is the 15%, calculate the speed of motor. Okay, I am giving again 4-minute time to solve this question and your time starts now. Earlier all 4 field winding were connected in series, but now they are regrouped. Now the 2 are connected in series with 2 parallel paths. The total series field winding resistance is 0.8. So now Mr. General Knowledge. You have 2 minutes 40 seconds. The question from the speed control of a series motor. It is under the topic of flux control of series motor. Speed of DC motor can be changed either by changing the armature circuit resistance or by changing the value of flux or by changing the armature terminal voltage. So it is a part of flux control method. By rearranging the series field winding, basically we are changing the value of flux. The flux is weakened by 15%. Earlier our 4 field winding is connected in the series, but now they are regrouped from all series to 2 in series with 2 parallel paths. As per Neeraj Kumar Maurya, the C is the right option. It's a very simple question. only the flux is going to be changed. Still, Saurav Roy, C is the correct answer. Ayan Malik, C is the correct answer. You have still 70 seconds. Last 5 seconds. And your time is going to be end now, and now your time is up. See, again, the first task is to draw the circuit diagram. This was my series motor. It is armature resistance. We have a 4 series field winding which earlier was connected in series. All 4 is connected in the series. The total resistance is the 0.8. Total resistance of this RSC, it is equivalent to 0.8. Armature resistance is 1 ohm. It is connected with the 340 volt supply and running at the speed of 1000 RPM. 340 volt supply. And taking the current of 12 ampere. Suppose in this condition, if the induced EMF is EA1. So what is the induced EMF EA1? In first case, the induced EMF EA1 would be terminal voltage minus voltage drop across series field winding plus armature winding. It is 340. IA is the 12. Overall resistance of field winding is 0.8 and armature winding resistance is 1. If you calculate, you will get 208.4. ये 230 वोल्ट था, सॉरी, दिस वाज द 230 वोल्ट. That is why he was not getting the answer. Suppose इसके अकॉर्डिंग ही करते हैं. We am taking the 340 volt. If I take the 340 volt here, into 1.8 minus 340, 318.4. Clear? Now you are rearranging this series field winding. See, the 4 coil, it is a 4 coil. So the resistance of a single coil will be the single field winding. Total resistance was 0.8 and we have a 4 winding. So resistance of a single series field winding is the 0.2. Okay. Now we are rearranging this field winding into 2 parallel paths. And in each parallel path we will have the 2 series winding. Now this is my field winding. Now they all are arranged in the 2 parallel path, and in each parallel path we will have the 2 series field winding, 1 and 2, 1 and 2. This is armature resistance RA and this is armature. Suppose in this condition the induced EMF here is EA2. Again you are giving the same supply voltage 340 it is taking the same amount of current. Ampere. But now see, the overall series winding resistance will be changed because the resistance of a single field winding was 0.2. So it is the 0.2 plus 0.2. Total is become 0.4. The equivalent resistance of this is 0.4. Equivalent of 0.4. So overall equivalent resistance become 0.2. So overall equivalent resistance of series field winding, because we have a two parallel path and each have the equivalent resistance of 0.4. So now RSC is become 0.2. RA is the same. RA is 1 ohm. So now what will be the EA2? VA minus again current that is coming into the armature is the 12. Now the RA plus RAC. RA is 1 and now RAC is become 0.2. So 1.2 into 12 minus 340. It is 325.6. It has become 325.6. Clear? Okay. So now come to this point. Induced EMF, it proportional to the flux and speed. In previous case, the induced EMF was EA1. Flux was phi1, just I am using, and speed was N1. In second case, the induced EMF is become EA2. Flux is become phi2 and speed is become N2. If I divide these two equations with each other, it is become phi2 upon phi1 into N2 upon N1. EA2 is 325.6. EA1 was 318.4. Now see, in second case, the flux is weakened by 15%. So earlier when the flux was phi1, it weak by 15 flux. 15% means the phi2 is phi1 minus 15% of phi1. So it has become phi1 minus 0.15 of phi1. So it has become 0.85 of phi1. N2 we have to find out. N1 is given. EA2 is coming 320. 1.2 into 12 minus 340. How? It would come 325.6. No? Okay, sorry. Line current is now 20. I took the same line current. Now the line current is at 20 ampere. So use this 20 ampere. Not here. यहाँ यूज करना था. गलत कर दिया सब जगह. Here it was same. Earlier it was the 12 ampere. So this is the same. In second case, it become 20 ampere. So it would be 20 into 1.2, 316. So you use here 316 in case of EA2. N1 is given. N1 was 1000 RPM. 5 1, it is the 5 1 5 1, it will be cancel out. So N2 will be 316 into 1000 divided by 318.4 into 0.85. Into 1000, 318.4 into 0.85, 1167. One 167.60. Approximate the C will be the correct answer. वो मैंने कैलकुलेट किया था by using the 230 वोल्ट. Clear? Okay. So now we move to the next question. This is the question number 10. A DC shunt motor drives a centrifugal pump whose torque varies as a square of the speed. That means the torque is proportional to speed square. The motor is fed from 200 volt supply and take 50 ampere when running at 1000 rpm. What resistance must be inserted in armature circuit in order to reduce speed to 800 rpm? The armature winding and the field winding resistance is given. It is a DC shunt motor. Now complete this question within 4 minutes. It is a part of armature resistance method, voltage control by changing the armature circuit resistance. In case of centrifugal pump or in case of fan, the torque is always proportional to the speed square. And in the DC shunt motor, the flux is a voltage control flux. It depends on the voltage. In series motor, the flux is a current control flux. It depends upon the current. So use two conditions. In first condition the speed is given, and in the second condition you have to find out the value of speed. If speed is changing, the torque is also changing. Take 50 ampere means the 50 ampere is the line current. It is taking 50 ampere current from the supply. It's a very simple question, dear. As per Ajay, D is the right option. Several times this type of question come in the exam. You have 15 seconds now. And now your time is up. Only one student gave the answer, and that too was wrong answer. See, first draw the shunt motor diagram. Circuit diagram of a shunt motor. This is shunt motor. RSH is 100 ohm. RA is given. RA is 0.1 ohm. Suppose the induced EMF here is the EA. We are connecting this motor with the supply of 200 volt, and it is taking 50 ampere current, 50 from the supply, and it rotates at the speed of 1000 rpm. Suppose it is taking 50 ampere current supply. So what is the value of ISH? The current that is going into the shunt field winding. So ISH will be the voltage across shunt field winding is the same as the terminal voltage, 200, divided by the resistance of shunt field winding, it is the 2. So the armature current IA, it will be the line current minus shunt field winding current 2. It is 198. Sorry, 50, it was the 50, na? 50. minus 2, it is the 48. Now, the torque here is proportional to speed square. Torque, and the torque is basically K phi into Ia. So phi Ia is proportional to N square. In the DC shunt motor, we are not changing the terminal voltage. If terminal voltage is not going to be changed, that means the current in the shunt field winding will always remain same. So the flux is remain same till the terminal voltage is same. So flux is the constant term here. So torque is only depending on the current, and the torque is proportional to speed square. So by using speed equation number 1 is equation number 2, the current is proportional to speed square. So armature current is proportional to speed square. So suppose in second case the armature current is IA1, and in first case armature current is the IA1. Second case speed is N2, and first case speed is N1. So by using this formula we can find out the armature current in second condition. IA1 we just find out, it is the 48. N2 we have to reduce speed from 1000 to 800. So in second case the speed would be 800. In first case the speed was 1000 rpm. So from this formula we can find out the value of IA2. It would come 30.72. Clear? Now in second case, what would be the induced EMF EA2? It will be VT. Terminal voltage does not change, but current is changed, IA2. RA is the same. So now VT is 200. Current has become 30.72. RA is 0.1. So EA2 would come 195.2. Clear? Now we all know EA1 upon EA2, it is K into phi1 into N1, K into phi2 into N2. In case of shunt motor, flux remains constant. Phi1 is equivalent to phi2 because we are not changing the terminal voltage. So directly EA1 upon EA2 would be equivalent to N1 upon N2. Who told you gate is postponed? Who told you? So what was the EA1? We have not find out the EA1 now. So let us find out the EA1. EA1 was terminal voltage VT 200 minus current was 48 into 0.8. It is 195.2. EA2 we already find out. So EA1 upon EA2 195.2 सॉरी मैंने यहाँ पर गलत कर दिया ना. इट वॉज ओनली EA1 ना, ये मैंने गलत लिख दिया. Forget about this. This is EA1. Now again find out the value of EA2. When we find out the value of EA2, in second case we are connecting a resistance in series of armature circuit. So 200, IE2 is 30.72. Armature resistance is 0.8 and we are connecting external resistance here, REX. Clear? This is REX. Now use this equation EA2 upon EA1. EA2 is 195. EA2 is 200 minus 30.72, 0.1 plus REX. I am writing it as it is. N1 was 1000 RPM, N2 is become 800 RPM. Just solve this equation to find out the value of REX. You will get 1.32. Clear? In second case, we have connected external resistance in series of armature winding. In second case, the current is changed from 48 to 30.72. How to find out this current 30.72? Because current is proportional to speed square. Because torque is proportional to speed square and torque is proportional to current here because flux is constant here. In case of DC shunt motor, if voltage is constant, the flux will remain constant. Clear? See, always remember, in DC shunt motor, the flux depend upon the voltage, but in series motor, the flux depend upon the current. No, we are planning to do the power electronics questions, but we will plan only for 1 or 2 days. It would start, I think, from, I will do this on next Wednesday before the gate exam. Okay. Okay, now come to the question number 11. A DC series motor drive a load, the torque of which varies as a square of speed, assuming magnetic circuit to be remain unsaturated and the line motor resistance to be negligible. Estimate the percentage change in reduction in voltage. Here we are changing the value of speed by changing the voltage, which will reduce the motor speed to half of its value than it was on the full voltage condition. This is a armature terminal voltage method. Again, I am giving you 4-minute time, and within 4-minute time you have to complete this question. How much the voltage to be reduced so that the motor speed is reduced to half of its full load voltage. Torque is proportional to speed square. It is a DC series motor. Neglect the motor resistance. Magnetic saturation is neglected means the flux is directly proportional to current. 25%. How much the speed to be reduced? Yes. Magnetic circuit to be remain unchanged. and the resistance to be negligible. We are changing the terminal voltage so that it reduces the speed half of its value in the full load condition. See 75%. It was very easy question. See, first understand what is the value. Just neglect the magnetic saturation means. This is my magnetizing curve. It shows relation between the flux and current. In series motor, the flux is created by the series field winding, and series field winding current is the same as armature current here. This is the flux. If we neglect the saturation, that means we will assume that it is a straight line. After some time it is become saturated, but we are neglecting this saturation curve. So the phi is directly proportional to current. So in case of series motor, the flux is directly proportional to IAC, and IAC is same as the IA. Clear? So it is driving a torque which varies as a speed square. So torque is proportional to speed square. Now we know the torque of a motor is depend upon K phi into IA. Since phi is also proportional to IA. So if I write something K1 into IA, so what will happen? The torque is become proportional to IA square. Clear? Because the flux is also proportional to current. So without magnetic saturation, the torque is proportional to current square. So with 1 and 2, torque depend upon speed square and torque depend upon the current square. That means the current square is proportional to speed square. So from equation number 1 and 2, this left hand side term is same, so right hand side term should also be same. Speed square is proportional to IA square. That means IA is proportional to speed. Clear? Now we have to reduce the speed to half value. That means IA2 upon IA1. It is N2 upon N1. We have to reduce speed half of the speed N1 value, half of the previous value. So this may be possible only when IA2 would be half of the IA1 divided by 2. Clear? If resistance is neglected, if we neglect the resistance, that means the voltage drop is also neglected. If voltage drop is neglected, that means the terminal voltage will be equivalent to the induced EMF, because we are neglecting the voltage drop. So it will be equal to the induced EMF. Okay. Now come in first condition EA1, it is K phi 1 into N1. In second condition EA2 is equivalent to K phi 2 into N2. Clear? So if you divide EA1 upon EA2, it is phi 1 upon N1, phi 2 upon N2. E1 upon EA2, E is equivalent to voltage, so it is the V1 upon V2. Phi 1 and phi A2. Phi 1 depend upon current IA1, it depend upon the current IA2 because the flux is proportional to current. N1 upon N2. So V1 upon V2, we just find out IA2 is the 2 times of IA1 is the 2 times of IA. It is become 2 times of IA2. And N2 is the half of the N1. So V1 upon V2 is become 4. Clear? So how much the voltage is changed? Earlier the voltage was V1 and then it is changed to V2. So change in voltage V1 minus V2 in term of percentage as compared to previous voltage multiply by 100. This is the percentage in voltage. So V1 minus V2, you can say it is the V2 upon V1. One upon 4. If V1 upon V2 is the 4, it has become 1 upon 4 into 100. So 3 upon 4 into 100. How much it would be? 75%. So you have to reduce the voltage up to 75% so that the speed is reduced by half. I was supposed to start the power system, but they are saying that we should start the power electronics because mostly student is demanding about the power electronics. Clear? Okay. So now we move to the next question. A 10 kilowatt 230 volt 100 ampere 1500 rpm DC series motor has following full load losses expressed in term of percentage of motor. Armature ohmic losses, it is in term of input power 2.2%, field ohmic losses 2%, rotational losses 8.8%. Neglect the magnetic saturation. If motor draw half of the rated current, then what is the speed of motor? It is a combination of losses plus speed control method of the motor. So your time start now. Yes, पावर सिस्टम पार्ट 2 मैं आपको संडे तक दे दूंगा, ठीक है? संडे मंडे तक आई विल गिव यू द शॉर्ट नोट्स ऑफ द पावर सिस्टम पार्ट 2. 10 kilowatt is the output power and these losses is the percentage of in term of input power. In the rated condition, the motor rotated at the speed of 1500 rpm. If motor draws half of the rated current, then what would be the speed of motor? In case of series motor, the flux depend upon the value of current. So if you are changing the value of current, the flux will also be changed. Yes. Through these questions, from solving these problems, we are able to revise overall all concept of the machine. Yes, 1 minute 30 seconds remain. These all are the rating of series motor. 230 volt, 100 ampere. So you still have 20 seconds. Nobody is able to do this question. C 2862, no. Okay, let me do this for you. See, 10 kilowatt is the rated output power of the series motor, and you will get this rated output power when you apply the rated voltage and the rated current. This is my input current. So input power, this will be the, you will get the 10 kilowatt output power when you apply 230 volt and the current flowing is the 100 ampere. So this is the at the time of full load condition, So at the time of full load, what will be the input power? It is voltage multiplied by current. So whenever you apply the rated voltage and rated current, then only you will get the rated output power. So it is 23000 watt. This is my input power, and all losses are given in term of percentage of input power, percentage of motor input. So what is the armature ohmic losses? Armature ohmic losses and the field ohmic losses is the 2%. So total losses because in case of series motor, same current is flowing in the series field winding and the armature winding. So it is become 2.2 plus 2. So total ohmic losses is the 4.2% of this input power. So in term of watt, it is become 4.2 multiplied by 100 into 23,000. If you calculate, you will get the 966 watt. This is my total ohmic losses in the field winding and the armature winding. Now we know it is Ia square armature winding resistance plus series field winding resistance. It is 966. Ia we know Ia is the same as the line current, 100 ampere. So this is 100 square RA plus RAC 966. So from this we can find out the value of RA plus RAC. It would be 0.0966 ohm. Clear? So this is the overall resistance of armature winding and the series field winding. So we know at the time of full load, the full load current is flowing, 100 ampere current is flowing. So at time of full load, armature current flowing is the 100 ampere and it is rotating at the speed of 1500 rpm. This is the 1500 rpm is rated speed. So what will be the induced EMF at that time of full load? It will be Vt minus Ia1 Ra plus RAC. Terminal voltage is 230 volt. At that time of full load, 100 ampere current is flowing and Ra plus RAC is the 0.0966. So induced EMF at that time of full load will be 220.34 watt. Clear? And at this time the motor is running at the 1500 rpm speed. Now motor draw half of the rated current. If motor is running at the half load, then what will be the speed? So at half load, what will happen? The current is become half of the previous current. Now the only 50 ampere current would flow and speed we have to find out. In case of half load, what would be the induced EMF? Vt minus Ia2, resistance remains same, Ra plus RAC. So it is 230 minus 50, 0.0966. It will come 225.17. Clear? So we know induced EMF depend upon two parameters. One is the flux and second is speed. So Ea1 upon Ea2, phi1 upon phi2 into N1 upon N2. Now we have to neglect the magnetic saturation. That means the flux is proportional to current only. So Ea1 upon Ea2, it is proportional to current Ia1 and phi2 is proportional to current Ia2. Ea1 220.34, Ea2 is 225.17. Ia1 100 ampere, Ia2 was 50 ampere. हाफ लोड पे आपको निकालना है. N1 is given 1000 rpm and you have to find out the value of N2. Just calculate this equation, you will get 3065.76 rpm. So see, to solve this question, you do not need this data. Rotational loss is 8.8%. So sometimes the examiner give extra data just to confuse you. Clear? So sometimes they give this. कितना आ रहा है? 1500? What is that 1500? तो ये आ रहा होगा ना? So sometimes they give the extra data just to confuse you. So don't bother about this rotational losses. Okay. Now we come to the next question, the question number 13. It is on the braking part of DC motor. A 15 kilowatt 240 volt अच्छा एक सेकेंड ओके इट इज 1500 मैंने यहाँ पर yeah, that is correct. A 15 kilowatt 240 volt 150 rpm 72 ampere DC shunt motor has the armature resistance of 0.3. Neglect the shunt winding shunt field current. The motor is braked by plugging when working at the rated condition. What is the total braking torque? Not initial braking torque. You have to find out the total braking torque. If IA is limited to 1.2 times of the rated current, at the time of plugging, the armature current is become very high. So we use a external resistance to limit the value of current. So we are using a resistance so that the current is limited to 1.2 times of the rated current while plugging. So you have to find out the total value of plugging torque. $15 kilowatt 240 volt 150 rpm is the rating of DC shunt motor. Total plugging torque means the initial plugging torque plus the load torque. It is called the total plugging torque. Okay. Did not use stopwatch here. This we do not require. We require the stopwatch. I will give you 3-minute time. Total braking torque means the initial plugging torque plus the load torque or the developed electromagnetic torque. Initially the motor is running in the rated condition. Then you are applying the braking by using the plugging. नहीं, I will teach only in BYJU'S Exam Prep. Now you will learn a new concept here. What is basically the total braking torque? If you not learn total braking torque means the initial braking torque plus the load torque. It is called the total braking torque or the total plugging torque. B 210. Yes, and you are right. These data is the rating of motor 2521. Fifteen kilowatt is the output power. 150 RPM is rated speed. This is the rated output power. So see, in the operating point, in operating condition, the developed torque is equivalent to the load torque. The developed torque is equivalent to the load torque. So load torque is equivalent to the developed torque. The 15 kilowatt is the output power. So what is the torque? It is the power divided by speed in radian per second. At the time of rated condition, it is giving 15,000 output power, 15 kilowatt omega, and it is rotating at the speed of 150 rpm. So it is 2 pi, sorry, it is the 1500 rpm, not 150. 2 pi into 1500 divided by 60. If you calculate, you will get the torque, load torque is equivalent to 95.43. It is also equivalent to the developed torque, because at the time of operating condition, maybe due to this wrong data, you are getting the wrong answer. So torque is K phi into Ia. K phi. Phi is always remain constant in case of DC shunt motor. So I am assuming this K multiplied by phi as again a constant term Km. So this TE become Km multiplied by Ia. Ia is the full load current. It is the 72 ampere. So from this we can find out the value of Km. T is 95.743 and Ia is the 72. So it's come 1.3263. This is the value of Tm. Now at the time of plugging, the current is flowing 1.2 times of the rated current. So initial plugging torque, suppose if they ask about the initial plugging torque, so torque is Km multiplied by I. Km is 1.3263, but now current is 1.2 times of a rated current, and the rated current was 72 watt. So it is 114.592 Newton meter. Clear? This is my initial plugging torque. The total plugging torque would be initial plugging torque plus load torque. Plus load torque. Initial plugging torque is 114.592 and load torque was, sorry, ये load torque है, it is, load torque is the 95.43. If you add these two terms, you will get 210.085. Maybe you are getting the wrong answer due to the speed. Good evening, Pooja. तो आपको ध्यान में रखना है, अगर आपको खाली इनिशियल प्लगिंग टॉर्क पूछा है तो आपको ऐसा निकालना है, बट इफ द एग्जामिनर इज आस्किंग अबाउट द टोटल प्लगिंग टॉर्क, सो इट वुड बी द सम ऑफ द इनिशियल प्लगिंग टॉर्क प्लस the torque at which the motor was running. Since the motor was running in the full load condition, so I took the full load torque. Okay, so now move to the second last question of this class. A 20 kilowatt 250 volt DC series motor running at 1000 rpm under full load condition. The flux per pole is related by this equation. It is I divided by 50 plus I. I means current. RAC is given. Resistance of series field winding. Armature resistance is given. And the armature demagnetizing ampere turn is 6% of the field ampere turn. Means due to the armature reaction, the field magnetic field is reduced by 6%. Overall flux is reduced by the 6%. ब्रश वोल्टेज ड्रॉप, ओवरऑल ब्रश वोल्टेज ड्रॉप, नॉट पर ब्रश नहीं लिखा हुआ, इट इज ए ब्रश वोल्टेज ड्रॉप 2 वोल्ट. कैलकुलेट द जनरेटर टर्मिनल वोल्टेज इन केस जनरेटर इज डिलीवरिंग 100 एम्पियर एट 1050 आरपीएम स्पीड. ओके, अगेन you have to complete this question within 4 minutes. Flux per pole depend upon the value of current. We have to find out the terminal voltage when it is rotating at the speed of 1050. A 248.8. This is the second last question. C 268.6. No, both answer is wrong. The flux is depending upon the value of current. Series generator, the current, armature current, line current is the same, and due to the armature reaction, the overall flux is reduced by the 6%. Because we have a two type of effect of armature reaction. One effect is the demagnetizing nature, and second is the cross magnetizing in nature. So due to demagnetizing effect of armature reaction, the overall flux is reduced by 6%. The speed is given in both condition. Previously it was running at 1000 rpm, and in next condition it was running at the 1050 rpm. Still you have 30 seconds to solve this question. D. Ayan Malik, Rohit, D. No, D is not the correct answer. In full load condition, speed is given, and when generator is giving 100 ampere current, then again the speed is given. Just you have to find out the induced EMF in second condition. See, so at full load condition, the output power is the 20 kilowatt and voltage at which this power is being given is the 250 volts. So what is the current? Power divided by voltage. 20 kilowatt means 20,000 and voltage is equivalent to 250. It is the 80. So what is the flux? Flux is equivalent to I upon 50 plus I. So I am using a constant term K to remove the proportional sign. I is the 80 and 50 plus I, 50 plus 80. Clear? But due to armature reaction, this flux is reduced by 6%. So overall resultant flux will be the 96% of this flux, because 6% flux is reduced. 94% of this flux, 0.94, (130). It would be 0.64 into K. ये आ रहा है 0.94 into 80 divided by 130. 0.57 आ रहा है ना, I think it was 0.96 into 80 divided by 130. (0.590) सॉरी, या इसी के अकॉर्डिंग ले लीजिए. चलिए मैं उसके अकॉर्डिंग ले लेता हूँ. एक्चुअली फ्लक्स इज रिड्यूस बाई द 4% था यहाँ पर. दिस वॉज द 4, सो इट इज द 0.96. क्लियर? ओके, ये आपको मिल गया. And in this condition, what is the induced EMF A1? It will be, it is a generator, VT plus IA, RA plus RAC, series generator. It is giving power at the 250 volt. Current is 80. Total resistance 0.01, 0.015. If you calculate, it will come 254 volt. This in case of first condition. Clear? Now, at second time, when it is delivering current at 100 ampere. So at 100 ampere current, now the flux is proportional to K, I upon 50 plus I. So the flux will be changed. It has become 100 plus 50. But the resultant flux is reduced by the 4%. So resultant flux will become 0.96% of this flux, 96% of this flux. So overall resultant flux will become 0.64 K. Clear? Because as per the current, depend upon the value of current. Now the induced EMF at the time of second condition, it is a VT plus IA, RA plus RAC. Vt is 250. Now Ia is 100. Ra plus Rac 0.01, 0.015. No. It is not giving at this voltage. Sorry. We have to find out this voltage. Speed is given. Sorry. Speed is given at which it is running. It is 1050 RPM. Okay. Now we can use this formula. EA1 upon EA2. K phi R1 resultant flux speed divided by K phi R2 into N2. So it will be cancelled out. EA1 we know it is 254. EA2 we have to find out. If you find out the EA2, you can find out the terminal voltage. Phi R1 0.590 K. N1 is 1000 RPM. Phi R2 is 0.64 K. N2 is 1050 RPM. From this you can find out the value of EA2. You will get 289.30. Now find out the terminal voltage. Induced EMF minus voltage drop across armature winding resistance and the series field winding resistance. It is 289.30. In second case, current is flowing is the 100, 0.01, 0.015. It would be 284.8 volt. B is the correct option. Yes. So first find out the value of induced EMF, because the speed is given at the both conditions. So use this formula to find out the value of induced EMF, and from this induced EMF you can find out the value of terminal voltage. Clear? So now we come to the last question of today class. Again it is from the braking part. A 400 volt 19 kilowatt 500 rpm DC shunt motor is braked by a plugging when running at the full load. Determine the braking resistance if maximum braking current is not to be exceeded twice the full load current. The efficiency of motor is 85% and armature resistance is 0.2 ohm. In case of plugging, the armature current is increased. So to limit this armature current, we use external resistance. So what will be the value of external resistance so that the armature current is not to be exceeded twice the full load current? 19 kilowatt is the output power. Efficiency is given and it is a shunt motor. Neglect the field winding current, because the field winding resistance is not given, so you cannot find out the field winding current. So neglect that value of current. At the time of plugging, the overall voltage across the armature circuit is become VT plus EA. This is the last question of today class. 2 minutes remain. Concept of plugging. And plugging is occurring at the time of full load, because earlier the motor was running at the full load condition. A 4.8, no. B 6.85. Ayan C 3.76. Kailash B 6.85. It is running at the full load condition. And at the time of full load, the motor is giving output 19 kilowatt, because it is the rated output of motor. So in case of full load condition, the motor always give the rated output power. Okay, let me do this last question. See, at the time of rated condition, the output power of motor is the 19 kilowatt and the efficiency of motor is the 85%. So we can find out the input power at the time of full load. So at full load condition, input power will be the output power divided by efficiency. Output power is 19,000 watt and efficiency is 0.85. This is my input power. Input voltage we also know, it is a 100 volt. We are giving supply at the 100 volt. So we can find out the input current. Because we know the power, it is 19,000 divided by 0.85. If you divide power by voltage, you can find out the value of input current. It is the 55.88. See, no doubt this is basically the line current, but if all other data is not given, then we may assume that the field winding current is equivalent to 0. We can neglect the field winding current, because in case of shunt motor, the resistance of shunt field winding is very high. So the shunt field winding current is almost neglected if you are not able to find out the value of shunt field winding current. So it is also the armature current. So from this we can find out the value of induced EMF. It is the Vt minus Ia into Ra. Vt is 400 volt. Ia is the 55.88 and Ra is 0.2. It will be 388.82. This is the induced EMF EA. We can think, see, during plugging time, induced EMF does not oppose the terminal voltage, balki induced EMF suppose the terminal voltage. It supports the terminal voltage. So it is now not Vt minus Ea. It is the Vt plus Ia. So it is equivalent to IaRa. But we add a resistance Rex, so limit the value of armature current 2 times of the full load current. So Vt is my 400. Ea we find out 388.82. Plugging by using the external resistance, we are limiting current to 2 times of this value. So 2 times of this value. 2 into 55.88. Ra is 0.2 and Rex we have to find out. Solve this equation, you will get the value of Rex 6.858. So this was the last question. So today we completed all the 15 questions, and through all 15 questions I try to cover complete concept of the DC machine, including the speed control of DC machine by using armature resistance method, voltage control method, flux control method. I also choose some questions from the braking part, which is the least explored part of the DC motor. We completed some question on the induced EMF, and we also did some questions on how to find out the induced EMF if the pole arc oblique pole pitch is given. So this is all about from the DC machine. And on Monday, because this class will not be happen on Saturday and Sunday, on Monday we will try to cover same concept through the question for the synchronous machine on Monday. Synchronous machine, which is considered to be the most toughest part of the machine. So please do join and inform other students so that they can also join us. So till that, good night everyone. Good night.